our last one. Let's take a look at this. We have a tank is being filled with a liquid, and we're given a function. L of t is given below, is the amount of liquid in liters in the tank after t minutes. So t is time. L is the filling of the tank, how many liters. So, and what we see is they're going to be asking questions about the inverse function here. Inverse of L, so that's the inverse function. We're given some other notation. So one of the things that's best to do when trying to keep track of the variables, because the variables will change places when we go to the inverse function, right? X becomes X, an inverse function takes, the forward function takes X and maps it to Y, sends it to Y. The inverse function, the input is Y, the output is X. But the meanings of the variables don't change. So t is in minutes, so let's do that. T is a variable and it's in minutes. And L is the other variable, and that is a liquid measured in liters. Okay, that'll help us do that. And so then they introduce some other variables here. I'll take X to be the output of the function of L. So usually I don't know why we need X, but well, we could write it as L, or X is the same thing. L is the output, it's liters, X is liters. So whenever we see X, we're going to think liters, T minutes, and it'll help us. So then as we go through which statement best describes L inverse of X, well, what is L inverse of X? Remember, L inverse of X, excuse me, L inverse of X, as up here, well, that's T. So it's a value, it's going to be minutes, how many minutes it takes for something to happen. So it's the amount of time in minutes it takes to have X liters of liquid. That seems to make sense. So I think this is going to be it. But I'm going to go through here. The reciprocal of the amount of liquid in meters. Now this is a word that's meant to throw you off track. Reciprocal comes from the use of this -1 as an exponent. Because if I had 5 halves, or some number to the -1, this exponent is a reciprocal, and so I do get the reciprocal. But this -1 up here is not an exponent. It is it's a notation for the inverse. It's kind of, we use the same notation for two different things, but that's what they do in math. We just have to recognize when it's on a letter, when it's on a function, it's meaning the inverse, not the reciprocal. Okay, so you see the reciprocal, forget it. The amount of liquid in liters after X minutes, well, we already said X is not time, X is liters, so that doesn't make sense. The ratio of the amount of liquid in liters to the number of minutes X. Again, X is not in minutes, this cannot be it, but again, they're using this, the ratio is a fraction, maybe getting at slope or something, but X is not in minutes, X is in liters. So by labeling our variables, it helps us see, yes, indeed, it's the first answer that we thought it was, and the other ones are just kind of leading us off the track. Okay. Now they want us to actually find the inverse function. So what we do is we will start with the original function, and we'll replace L of t, because that's what they sort of tell us. We'll replace with X. So you get X equals 1.25 t plus 82. And then because of this notation, they're telling us if we solve for t, that means we're solving for the inverse function. Let's solve for t. So we would subtract 82 from both sides. And then we'll divide by 1.25. So now, if you give X as the input instead of the output, you would be able to calculate t. This is the inverse function. And we write it as inverse function with x as its input, right? So that's it right there. We don't have to simplify it any further. It's perfectly fine as it is. And then finally, they want us to find a value of the inverse function at 130. And we're plugging in x, that's liquid in liters. So this is going to give us how many minutes it would take. It would be nice if they put those units there. So we put 130 minus 82 over 1.25. We can calculate that here. Back to the home screen, let's clear everything out. And let's just take alpha F1 to get our fraction 130 minus 82 all over 1.25. We're just going to verify 130 minus 82 over 1.25. That's good. Let's hit enter. 38.4. They don't talk about rounding or anything, so we'll just put it in as 38.4. 38.4 minutes to fill up a 130 liter tank. That's how we go about doing that one with inverses. That's it.